Example 1. This is optimization part 3.
June the 30th. June the 30th, be with me.
Okay, just a reminder for our test for next week, guys. Whether you're writing it on Tuesday or Wednesday, we're going to have 2 graphs and 2 word problems. That's going to be on it. Okay, so after today, you will have seen every type of word problem possible. You should be able to, if you go through the word problems on the assignment, you should be able to handle the ones on the test. Okay, I'm not going to pick anyone from left field. So in the same way, if you do the graphs on the assignment, you'll have no problems with the ones on the test. On your choice assignment, I recommend strongly using Desmos just to verify. I'm going to embarrass Noah if you don't mind me doing that. Noah got an answer, he said it didn't make sense. It was good that he thought on the assignment, he thought that it said it didn't make sense. Right, so that's good to think that. We're going to go through today another examples like that to see how it goes. There's a small mistake we took care of it, but it's good to think that's like 1, 2.
Can we go over how to like find X intercepts again? It's like we kind of skipped over
X intercepts?
Yeah, of like critical points. No, not critical points. Like actual X intercepts, like where the line.
We don't know that at all.
Yeah,
Like some of them. Okay,
if you want to do it, okay.
Because then my graphs aren't gonna be.
Yeah, no problem. So if you need to find, hold on a second. If you need to find, the thing is, if it factors, you can do it. But if it's something that doesn't factor, and that's probably what's going to be the case.
Yeah,
if I give you a graph, if I give you an equation that looks like this. Okay, even I can't factor that one, and I'm not even exaggerating. Okay, so that's why the roots are less important. I set them up so that the critical points and the what's called points of inflection are doable. Yes.
Okay. When you like find an X intercept, like
Yes. Yes, just the numerator. Okay, good question. So the question was, why? Like, let's say that we did a question yesterday. I'm going to make up an example. 1 second. So if I do 0 equals, let me do something nice. Minus 1. Okay, let's say that I've taken my derivative and I got this. You don't write this down if you don't want to. Okay, but let's just say I wrote down that was my derivative. Why do I only need to solve the numerator is equal to 0? Well, because say, no matter what, let's say I have 0 over 10 million. What's 0 divided by 10 million?
0.
Good. What's 0 over 0.00001?
0.3.
What's 0 over negative 4.83?
0.83.
Right? So the idea is all that matters. Guys, what are you being like that for? Okay. The idea is only the numerator is the only thing that affects it equals 0, only for if it's 0. If it's anything else, then you'd multiply this across, right, and then solve it like that. Yes. So I'll do one of these on Monday, right? But then we do it for sure. So let's say for this one we're going to have x is equal to 1 and negative 1, right? So then you'd find f of 1, f of negative 1. Even though those are this is after first derivative, solve them back in the first equation. All right, let's do our 2 optimization problems. Both of these are on your assignment or something close to it. Okay. Example 1. Let's pick the easy one first. We'll do the difficult one. Example 1 says a natural gas company
Fake. Oh, I thought you said actual.
yes, lays underground pipe on both sides of a lake as shown. Okay, so here's point A, is the start. That's 500 meters. Here's point B, and that's 60 meters. And if you want to know, this is the lake. The lake looks sort of like this. Okay. There's one like this in the assignment, very similar to this question. Okay, we're going to say It costs $3 per meter underwater and $1.25 per meter on land. How far along the ground? Should the pipe be laid to minimize cost? Okay. And this is one that's very close to the assignment here. All right. Basically what I'm saying is this. We're going to go somewhere, some distance across the lake, or across like this. Let's say we pick a point here. What's the most, let's say I go from here to here across the land. What's the most direct way to get to point B? I see this, so it's going to go like this. So my picture's going to look something like this. Okay, is what it's going to look like. Are we all okay with where it came from?
Cool.
So we're going to lay a certain distance across the land.
Okay.
Then you're going to go from that point and go right to point B. Okay, are we all okay with the logic behind that? Okay, so now we need to put our X in and things like that. Okay, what's our unknown distance going to be? Sorry, go ahead.
Sorry, I'm just wondering, like, why do we have to go, like, along a certain distance?
You don't have to. If it's cheapest,
Go straight from A to B?
if it's cheapest to go like this, we can do it. Okay, but we're going to assume that there's some distance here. If it's zero, because the cost is so much more underwater though, the idea is it might be cheaper to go a little bit on land first. Okay, that's what we're going to assume. But this would work, it'll give you a higher cost, but they want to be, always when you build something, you want to go as cheap as possible. Okay, so let's assume instead of this, it's like $35,000 per meter, right? It's going to really make a difference. Okay, so, sorry, go ahead.
So you are letting it down, like, the same time while you're explaining like the
Yeah, so all we're saying is they're going to lay the pipe across this side, and then at a certain point they're going to say, let's go across directly to point
And
B.
that's because that, the one from the side, I mean, one from the side,
Yes. Yeah, A and B are going to be given, okay? So what I'm going to do, I'm going to draw this. I'm going to redraw this just a little different way, if you don't mind, just over here. So we need to make some equations in here. Okay? If I call this distance right here x, okay, from here to here, what is the left-hand red going to be? Yeah, go ahead.
500 minus X?
500 minus x, very good. Now you could have, in the same way, if you don't, whoops, 500 minus x. In the same way, if you don't like that, if you say, Mr. Sadler, like, I want this to be x, you can do that too, and x would be the distance across, and this one's going to be 500 minus x. I'm doing it this way because my equation is going to be nice. What is the vertical distance going to be? Go ahead. Just 60.
But you
Hold
said
on a
that
second. Just
you
wait,
did,
just wait, just wait, just wait. I know what she's going to say. And then this is going to be D. Okay? Go ahead, Chris.
but you said it's like you put it in the specific way that, because either one of those two parts could be 500 minus X in a way, and
Yes.
then the other one would be X.
Yes.
But you said that is to have a nice equation, but how do we know?
It'll still give you the same thing. The only difference is going to be, when I'm looking at this, how am I going to solve for D here?
Oh, true. Yeah.
It's going to be Pythagorean theorem, right? Okay. So what I'm going to do is here, I'm going to go to the next page one more time, and I get some costs in here. What's my equation for cost going to be? Well, what's the cost for this going to be? What do you say? How much? For the distance horizontal, how much is that going to cost per meter? 1.25. So it's going to be 1.25 times 500 minus x plus 3D. Now I have a slight problem with 3D. What's the problem that I have for 3D? I love saying 3D, as you can tell. Well, the problem is D doesn't have, we've got to make an equation for D still, right? Okay, are we sort of following along what I'm trying to do here? Okay, what's my equation for D going to equal? Yeah, Brendan, go ahead.
X squared.
Right, so I'm going to say D, it's going to be D squared, technically it's going to be that, but you're right on. Now, someone is going to tell me that D is going to equal X plus 60. It totally is not. Sorry, it literally is not. Okay? Yeah? Oh, good question, because this is underwater. So underwater costs $3 for every meter, okay? So then D is going to equal the square root of X squared plus 3600. Is everyone okay on that? Right, because you can't just square root each part, it's going to be the square root of the entire thing. So therefore my equation is going to be C of X is 1.25 500 minus X plus 3 X squared plus 3600 to the 1/2. Now please be brave, because again the math for this isn't hard after the first step, but I want to make sure we're okay on the first step. Haley, how are you feeling? Sorry, how are you feeling about this question? Sorry, that's a loaded question. How are you feeling about this example? Fine, okay, good. Random question. Got it? Okay, I'm going to hit pause the video and you guys are going to find out the minimum cost. How do you find the minimum cost? Make it 0, derivative equals 0. Okay, so take a second, try it right now, and then I'm going to hit pause in the video. Is that a question or your thought? Yeah, you can follow it in for this. You can follow it in. This we can't, right? But that we can for sure. Yeah. Yeah, it would follow it in for sure. Okay, so take the derivative of set it equal to 0.